Here we're going to talk about another feature of constraint. When we were making parent relationship, we mentioned before, all the objects we select will all be placed under the last object we selected as its child objects. If we select these and then select the last one and press P, then we'll see everything is placed under it as its child objects. This is a feature we also mentioned when we talk about parent relationship. A parent object can have multiple child objects, but a child object can only have one parent object. When it comes to constraints, it's a bit different. A driver object can have multiple driven objects. This is pretty easy to understand. For example, we can create some. We select one, then select another. We make a parent constraint, make another parent constraint. This way, when I move one, the other ones will all follow along, showing the parent constraint behavior. But at the same time, here's the thing, constraints are different from parent relationship. A single driven object can also have multiple driver objects at the same time. In fact, the selection order for constraints was designed with this logic in mind. For example, if we select these three objects, and then select this last one as the driven object, when we create the parent constraint here, what it's actually doing is taking all the objects we selected first, and making them driver objects that constrain the very last driven object. So if we click Constraint, find Parent Constraint, and we click it, we can see that only the last one gets the parent constraint. So we might be wondering, since we have multiple driver objects, which one does it actually listen to? This brings us to another really important concept in constraints: weights. We can see here there are three attributes. These three attributes correspond to, we can actually see just by reading the names, they are the names of our three driver objects. And after them, there's W0, W1, and W2. The W here stands for weight, and the 0, 1, 2 is just computer indexing. It always starts from 0, the first, second, and third. By default, all three have the same amount of control. It's basically a percentage. These three add up to 100%. If the three of them add up and it's not a complete one, Maya will automatically normalize them based on their ratio. For example, right now all three are 1. So Maya just assumes that each one, because there are three of them, each one gets a 33.33% share. So if we try to move one, we'll also see it doesn't have 100% control. Instead, it has 1/3 of the influence, 1/3 of the influence, 1/3 of the influence. So if we change this, let's set the first one to 1 and the other two to 0. Now if we take a look, it's completely controlled by the first one. The other two have no effect on it at all. And if we change this to 0.5 and 0.5, then in this case, the third one has no effect at all. And the first two will have the same percentage of control over it. And of course, we can change it again. Let's say this one is 0.2, this one is 0.5, and this one is 0.3. This way, this one has 50% control, this one has 20%, and this one 30%. So this is also something with constraints, not just parent constraint. It includes the ones we'll talk about later, like point, orient, and scale constraints. It's actually the same behavior for all of them.